Alright, students, we are back to our content of engineering level 3. So for now, our focus is all about chapter 3. Chapter 3, we are talking about forces. Anything that's going to deal with forces will be discussed under chapter 3. So our very first objectives of the lesson for today, so just the objectives or the focus, what we are going to focus on for today, we are going to look at the conditions of equilibrium that was actually discussed already in chapter 2, and we'll also look at the definitions of terms. So these terms we are referring to the resultant, we are talking about the equilibrant, then comes the equilibrium, and our last object that will be discussed here will then be the dealing with triangular forces and dealing with parallelogram just a moment, I'm trying to manage my space. So we are going to look at parallelogram of forces. Okay, so those are our objectives. So that means we are going to look at conditions of equilibrium, the definition of these terms, and we will look at parallelogram of forces and triangular forces. So now, so kicking off with force itself, I'm sure you can remember very well the definition of force from level 1. So we said is the influence that changes or tries to change the state of rest or uniform motion of an object, and this is done in a straight line. Okay, so we are saying the influence that tries to change the state of rest or tries to change the state of uniform of motion of an object, but in a straight line. So force is a vector quantity. I'm sure you can remember that. Force is a vector quantity. Why? Simply because it consists of both magnitude and direction. Okay, so it actually consists of both magnitude and direction. The SI unit The SI unit of force, I'm sure everyone can remember this, is actually Newton, and we represent this in a capital letter N. And a force is normally represented with a straight line okay, drawn to a suitable scale. With an arrowhead. Okay, so that means your line should have an arrowhead. For example, I can then have a very straight line. We are saying this line should have a scale, so that means we can say I have 1, 2, 3, then 4, up to 5. You can see I'm increasing by 1, and I'll put on an arrow. Okay, so that means if I say give the value of this or the magnitude of this, we are saying our magnitude of this is 5. Okay, let me say this are meters. Okay, so that means I'm going to say I have 5 meters, and this is going, you can see the direction is indicated by the arrow that is basically to the east. That means I have both the magnitude, so I do have the magnitude over here, and I have the direction right there. Okay, so that means we have those two, both magnitude and direction, and should be represented with a straight line. This is just a recap of what we guys did in level 1 and 2. So there are some 4 aspects. So we are saying 4 aspects that defines a forcefully. Okay, so we have 4 aspects that actually defines a forcefully. So number 1, we are talking about magnitude. Okay, then we have direction, then you have point of application, then lastly we do have, it is nature. Okay, the nature of the force. For example, is it a pushing force or is it a pulling force? That's what we mean by the nature of the force. Okay, so that means you define your force fully using those 4 points. And when we mean fully, we are saying completely. Completely. What exactly does it mean? That means if you know someone in and out, you know this person, what the person likes, what the person doesn't like, where this person will mostly hang, and what type of sport does he watch, and what kind of car does he drive. So that means you know the person fully. So now we are saying we also know the force fully. For me to know the force fully, I need to know all these 4 points. I need to know how big is the force, that's the magnitude. What direction is the force going? Where was the force applied? The point of application, where is the force applied? Okay, basically that's what it means. Where is the force applied? Okay. Right.